Hello, Mrs. Stolle here. So today we are looking at quadrilaterals, okay? And we need to understand what quadrilaterals are. So quadrilaterals have got four sides. So it's just shape with four sides, okay? But when we are looking in grade 10, this is where you start to actually go deep into into quadrilaterals, okay? Now, what you see with the quadrilaterals, we have got normal quadrilaterals, but we have the special quadrilaterals here that we have. And these special quadrilaterals, we call them parallelograms, okay? Parallelograms, okay? Now, what are these parallelograms? We want to know what are parallelograms, okay? So what makes a quadrilateral a parallelogram is that the opposite sides must be equal. Okay, so a pair of opposite sides must be equal. That's what we are saying. Then the other thing that we must also know with quadrilaterals, with the parallelogram, is that opposite angles are equal. So we are saying opposite angles, opposite interior angles, they are, they are equal. Okay, now, when we are saying opposite angles are equal, we are saying here B is equal to D, and also A is equals to C. Then what else can we also say? We say that AB is equals to DC, and also AD is equals to BC. That's what we've explained so far. Okay. Now, what else can we add to make out the triangle, the quadrilateral parallelogram? Is that the opposite sides are parallel. Okay. So the opposite sides are parallel. So what we expect to see is that your AB, let's use another one here, your AB, okay, is parallel to DC, and also your AD is parallel to BC. That's what we see. So these two are parallel, these opposite sides are parallel. Then what else can we also add? Let's also discuss perpendicular, perpendicular, not perpendicular as such, but the bisectors. So here, when you look at the diagonals bisect each other. Diagonals bisect each other. So it means that this side here, if we are to call this part E, what we see that DE will be equals to EB. Okay, then what can we also add? We are saying AE will also be equals to EC. So that's what makes a quadrilateral, a parallelogram. Okay, so this is our our parallelogram. Now, we have got three types of parallelograms. We have the first one is a square. Okay, and the second one is a rhombus. Then the third one is a rectangle. Okay, what can we say about a square? A square, you see that with a square, it is a parallelogram, but what is an additional to that? What is an additional here is that diagonals bisect each other, and again, they are equal. So here, diagonals are equal. So they bisect each other, and they are also equal. And what else can we add is that diagonals are perpendicular to each other. So it means that here, the angle they meet at is actually 90. Okay, then what else can we also add about the diagonals? Diagonals bisect the vertex angles. It bisect the vertex angles. So that's what we see. We see that that angle is equals to that angle. And let's just put the same color because they are all equal. Okay, so here they are all equal. That's what you must know. Just like they are by the diagonals, they are also equal. Then the other thing that you must know is that the interior angle of a square is 90. Okay, so it's also 90 here. Interior angle of of a square is 90, and that makes it a square. Then another thing again is that the sides, all sides are equal. So what we see is that all sides are equal. That's what we see. Okay, so not only that opposite sides are equal to satisfy the property of parallelogram, but also all of them, they are equal when we are looking at a square. Okay, now let's jump to a rhombus. A rhombus, I could say it's more of a twisted square. Why am I saying that? Because you can see that all the sides are equal. But what also you need to understand is that the diagonals again here, but they meet at 90. So here, diagonals again, they meet at 90, but they are not equal. Okay, they are not equal. It's only special for the for the square, okay, where the diagonals are equal. But in this case here, diagonals are not of the same size. That's what we must understand when it comes to rhombus. Then another thing is that it also bisect the diagonals also bisect the vertex angles. So what we see is that this is what I mean when we are saying it's bisecting. This side here and this angle here will be equal in that case. That's what we are saying here. Okay, now then let's move on to a rectangle. What is special about rectangle? What's special about rectangle is that interior angle is 90. Okay, interior angle is 90, but the rest you can still refer back to a parallelogram. Okay, so there is nothing much here for a rectangle. Just know that it's a parallelogram. Everything that I have said up here should actually apply also for the a rectangle. Now, so these are parallelograms. So we've got the square. So let's just say the square, the rhombus, and also the rectangle. Okay, so that's what we have there. Now let's move on to the other types of quadrilaterals. These we call them the trapezium. So we have what we call a trapezium. Okay, trapezium. Now, with the trapezium now, opposite sides are parallel to each other. Okay, so one pair of opposite sides are parallel to each other. Okay, that's all what you need to understand there. Then when it comes to what call the fourth, the second quadrilateral again here is what you call a kite. Now, what about a kite? A kite, adjacent sides are equal, and also the long diagonal bisect short diagonal. And again, the diagonals, they meet at 90. Okay, so now let's see what theorems should we learn at this stage. Now, when you look at a theorem, is actually what you call been proved. So it's something that have been proved that if you are given that it's a parallelogram. So here, in this case here, you are given that it's a parallelogram. Okay, so a parallelogram given is a parallelogram. So they already told you that shape ABCD it's a parallelogram. Okay, that's what we know. Now, when we know that, what is it that we can conclude? What we can conclude is that opposite sides are equal. And what else can we also conclude is that opposite angles are equal. That's what we see. So that's what we can conclude there, because we are told that it's a parallelogram. So when we are working now with the shape that we are told that is a parallelogram, we will be assuming that we'll be knowing that the opposite sides are equal, and opposite angles are also equal. Now we will be using this information to to find what we want. Okay, because when you're given that it's a parallelogram, already you're going to use this information to add up to prove whatever you are trying to prove at that particular moment, because it's a theorem that you're dealing with. Now the same applies here when it comes to what called the converse. Now the converse, we are saying you are given part of the theorem, okay, to say, okay, opposite we are given a shape. This shape is not known that it is a parallelogram, but you need to prove it that it is a parallelogram. How do you prove that the certain shape is a parallelogram? That's what we are saying here. So here you'll be actually proving the quadrilateral is a parallelogram. So I will just use the shortcut, guys. I will use the shortcut here. So you'll be saying the lines are for the parallel, then it just parallelogram ending with an M there. Now, so we are saying this is what you're doing when you're dealing with this. So here you're proving that a certain quadrilateral that you're given, it is a parallelogram. But how do you do that? When you are given a parallelogram, you can prove that opposite sides or opposite angles, are equal. So if the opposite sides are equal, then, so we are saying here, if we are saying opposite sides are equal, if opposite, why am I saying side here? Angles are equal, then A, B, C, D will be a parallelogram. That's what we are saying. That's what we are saying. But here again, what about this part here? My apology for that. I added the wrong wrong part there. It should be the opposite angles here. I don't know why I'm putting. I keep on saying applying for sides. Okay, so we should be seeing that here, where we are saying the opposite sides are equal. So if that you are given a quadrilateral, you don't know it's a parallelogram, you are going to prove that, okay, opposite sides should be equal. So if you prove that they are equal, then you can now say the shape is a parallelogram. So if opposite sides are equal, then ABC D is a parallelogram. That's what we are saying here. So that's what the converse is doing for you. Okay. So now let's look into another theorem. So we're looking at the theorem. A theorem. Theorem 2. Okay. That was theorem 1 there. So theorem. Okay, now let's look at theorem 2. Theorem 2 is saying diagonals of parallelogram bisect. Diagonals of parallelogram bisect. So when we are given that the shape is a parallelogram, then we can now say, okay, so if we're given that it is a parallelogram, okay, so we can now say, we can safely say the diagonals bisect. We will be using this information now. So we can apply wherever we are calculating, we can apply that concept to say diagonals are bisecting. So whichever sides here, you must know that they are equal based on the theorem that you know. Okay, that falls under your parallelograms. Okay, now what about the converse of that? The converse now is now showing that you find that you are given a quadrilateral. Here again, we are saying in the theorem, what are you given? You are told that it's a parallelogram. Okay, it is a parallelogram that you're dealing with in this case. It's a parallelogram, and you have it is a parallelogram. Okay, now here you are given a quadrilateral. Okay, you're given a quadrilateral and you need to prove that it is a parallelogram. Okay, so you can now say, okay, what you'll be proving here, you'll be proving that what is it? You'll be proving that, so let's call this E, A, E will be equals to EC, and DE will be equals to EB, like that. Okay, so that's what you'll be proving there. That's what you'll be proving there. So we will know that, okay, what is it? If we find that these are what called diagonals are bisecting, then now we can be able to say, oh, this shape is a parallelogram. This quadrilateral is a parallelogram. That's what you're saying here. Okay, so that's just know what to do when you're given a question. Now, what is this last part here? This last part here is actually the last theorem. What does your last theorem say? It also says if one pair of opposite sides are equal and parallel, then what is it? It is, what is it? A parallelogram. So in this case here, if one pair of opposite sides, so you're saying here, if one pair of opposite sides are parallel and equal, then we can safely say that is what is it, a parallelogram. Okay, that's what we are saying here. So here you are proving that it is a parallelogram. It is one of the things that you must know, that you are proving it's a parallelogram. Okay, now what is it that we should actually look at here? Let me just bring in this. Let me see here. Okay. So given that, okay, what must we do here? To prove that a quadrilateral is a parallelogram. Prove one of the following. So you must prove one of these what is it? Sorry, my handwriting here. You must prove one of these one of the following. Okay, so number one, you must prove that AB is equals to DC, and also what is it? AD will also be equals to BC. Now, why will we be saying that? Because the opposite sides must be equal. Here, number two, A must be equals to C, and D must be equals to B. Okay, what about number three there? Number three, we must know that what is it? Our opposite sides are parallel, so we are saying AB must be parallel to DC, and or what is it? AD also parallel, not or, but you must find both that is parallel to BC. Then you can now say what you call opposite sides are parallel. Then number four, what must we see? We must see the diagonals bisecting each other. So what we see also here, the diagonals bisecting each other, is going to be AE is equals to EC, and also DE must be equals to EB. So if you are able to prove any of these, then we know that you are coming right. Now, then what else can we also, what is it, add there? We can also add that one pair. So it means that either, number one, you are able to show that AB is equal to DC, and also AB is parallel to DC. Or number 2, you need to be able to tell us that AD is equal to BC. So it's oral here. And what is it? AD is parallel to BC. So in this case now, we are now able to say, okay, if you prove any of these, when you ask to prove that a shape is a parallelogram, you must just show us any of these. Then in that case now, you know that you will be coming all right. Okay, now let's look at maybe a question, then we can understand how we apply this. Now, in the first question that we have here is that we are asked, determine the size of the interior angles of parallelogram ABCD. Now, when we are told that it is a parallelogram, now we know that we can now know that, okay, if it's a parallelogram, opposite sides are parallel. Now, if opposite sides are parallel, looking at these two triangles, we are saying they are co-interior. So these two angles here, these are co-interior angles. Now, what do co-interior angles do? Co-interior angles are, what is it? They add up, they are supplementary, meaning to say they add up to 180. So that's what we know. So we can now use that information to calculate what you call the angles. So now what are we going to do here? We're going to say, okay, A plus D must be equals to 180. Okay, why? Co-interior angles, supplementary. So your co-interior angles are supplementary. Why are you saying that they are supplementary? Because we know that AB is parallel to what is it? To DC. That's what is actually giving us that confidence. So here, this is what you need to understand, guys. So that's what you need to understand there, okay? That this is how you should actually write it. Now, in that case, now you're now going to say, you have already given your reason. So what you are going to do now, you don't need to give a reason to calculate X for now. But now let's see what we're going to do here. 2X minus 30 plus 2X plus 10 should give us what we call 180. Now, when you solve this, we find that X is equals to 50. Now it means that we can now substitute there and say, okay, A is equal to, so here we are saying A, what is it? It's going to be equals to 2 times 50 minus 30. Okay, which is going to give us what call 70. Okay, now what about D? D is going to be equals to what call 2 in bracket 50 plus 10. That will give us 110. Okay, so that's what we have there. So we now know that, okay, there is 110, there is 70. Then what can we also say now? Because remember, we want to calculate all the interior angles. So now we are left with B and C. But now what can we do? We know this stuff. Now we know that we are given that it's a parallelogram. Now if it's a parallelogram, opposite angles should be equal. So here what are we going to do? We're going to say what is good? B is equals to what is it? 110. Opposite angles of a parallelogram are equal. Then what else can we say? We can also say, C is equals to 70. Why? Opposite angles of parallelogram equal. That's what we have. That's what you need to do. So we have found everything, and we are able to actually to proceed in that case. So that's what you need to understand, guys. That's what you need to understand, that this one here is going to be 110. So let me just use another color here. This one is going to be 110. This one is going to be 70. But you're not just writing. You are supporting whatever you say with a what you call a statement. Now, let's go on to the next one. Now, looking at this shape here, we're told that KLMN is a parallelogram. So we're already told that this is a parallelogram, okay? Calculate the size of the interior angles. We are faced with the same question again. But to start, what are we going to say? We are going to say, okay, K is equal to M. Why are we saying K is equal to M? So the answer here, we are saying opposite angles of parallelogram equal. Then from there, we know that we can now calculate that using the using that information, because we're going to say 5x minus 12 should be equals to 3x plus 18. Then now we're solving this as a algebra. So here 5 minus 3 is going to give us 2x. Then we take the 12 that side is going to give us 30. Then we are going to have 2 there. X is going to be equals to 15. So here the angle here, the x is 15. So meaning to say, we are now going to say, okay, what's our k now in that case? K should be equals to 5. 5 times what? Times 15, okay, minus 12. Okay, let's see what we get there. So it's 5 times 15 minus 12. What do we get? We get 63. So we're getting 63 there. Okay, now when we get 63, we already know that this side also, since these are equal, this is going to be 63. This is going to be 63. There is no need for us to actually calculate to find what is the angles, what is 3x plus 18, because we know that these two are equal. Okay, so now what are we going to say now? Since we are told that it's a parallelogram, remember, you can just put your arrows. If they are not there, you can just put your arrows when you're told that it's a parallelogram. Now, in that case, now what are we going to do now? We're going to see, we need to get our n. What is our n going to be? Our n is going to be equals to 180 minus 63. Why? Co-interior angles supplementary. So the co-interior angles, they are supplementary. When you're saying they are supplementary, they add up to 180. Why are we saying co-interior angles? Because KL is parallel to NM. That's what we know. So in that case now, we can safely say those are co-interior angles, and they actually add up to 180. So we're going to say 180 minus 63. What do we get? We get 117. So we have got 117 here. Now, once we have 117 here, we can also now say L is equals to 117. Why are we saying that? Opposite angles of a parallelogram equal. Okay, so they are equal. That's what it means. So here, if they are equal, then we can say L is. So we now have all the angles that we wanted here. We now have all the angles that is needed. That's what you need to understand, guys, when you are dealing with parallelograms. Now let's go on to the next one. In parallelogram ABCD, AB is equals to AD. So AB is equals to AD. So I like to add AB is equals to AD. Now, if we are told that it's a parallelogram, again, we can also add now, because we're told that it's a parallelogram. So this side here is actually parallel to that side, and that side here is also parallel to that side. And again, this side here will be equal to that, and this one will also be equal to that, because these opposite sides should be equal. So I'm just saying you can just put those what you call down, then you won't have a problem. Now let's now go into the question. Calculate the size of all interior angles. Now we need to now know, we are given AB, okay, C is equals to 110. Oh, good start. So C is 110. Now when C is 110, let's calculate A, which is easy here. So we know that A is going to be equals to 110. Why are we saying 110? Opposite angles of parallelogram equal. Now, okay, what's next now? What's next? What we also see is that when we look at at angle here, this one 110, we can also find D1 and B1. Okay, we can also find B1 and D1. Okay, so this we can now say, okay, B1 is equals to what you call D1. Why are we saying that? Because these are angles opposite, equal sides. So where do we use this? When we are dealing with an isosceles. Okay, so when you're dealing with an isosceles, you know that this is what you're supposed to deal with. So it's either when you're given the sides that are equal, you can safely say angles, they also equal in that case. So here, let's indicate that they are angles. Okay, now what can we now say? We can now find B1. So B1 is going to be equals to 180 minus what is it? Minus it's going to be 180 minus 110 divided by 2. Let's see that. 180 minus 110. Okay, we divide that by 2, we can get 35. So here is 35. So what we now see is that we now have 35. We now have 35. But now when I have that 35, so it means that B1 is equal to 35, and also D1 is also equals to 35. Then what can we also say that B2 will be equals to 35. Why are we saying B2 is equals to 35? Let me put it in this way. Let me put it like this. B2 is equals to D1, which is equals to 35. So now we now have what we call B2. Let me not write it together like that. It's therefore B2 is equals to 35. Why are we saying B2 is equals to D1? Alternate angles. Why are we saying alternate angles? So alternate angles are equal. But where are we getting that? We are getting that because AD is parallel to BC. So AD is parallel to what is it? To BC. Why are we doing this? Because this is a parallelogram. We are given that. Okay, so once they are parallel, we have then alternate angle, the Z angle that we see there. That shows that D1 is equal to B2. Okay, now what else are we left with? So we are now left with what we call D2. What we can say is that BAD is equals to BC. Why are we saying AD is equals to BC? AD is equals to BC. Why are we saying is equal to BC? Opposite sides of parallelogram equal. So now we can also, since these two are equal, your DC is equals to AB. Okay, if your DC is equals to AB, then we know that these are also opposite sides of parallelogram equal. So now when we have that, we can now say, okay, if these two are equal, we know that AD is equals to, what is it, AB there as well. So it means that BC, therefore, BC will be equals to CD. Now, once we have BC equals to CD, this makes what? This makes an isosceles. So when you have the isosceles, we can now say D2 will be equals to 35. Why are we saying that? Because these are angles opposite, equal sides, because we have proved that this is an isosceles. This side here and this side are equal. That's why we are saying what called D2 should be also equals to B2. That's what we mean by that. Okay, so in this case, we just prove that B2 is equals to D2. Okay, that's what we need to know. So in this case now, we now have all the angles that we wanted. So 35, so 35, and also 35. That's what we have done there. Now, let's look at this one as well and see. ABD and BCD, ABD and BCD are two isosceles. So we are told that there are two isosceles triangles, okay? So when there are two isosceles triangle, we know what happens when they are isosceles. The base angles are equal, and also, what is it? The sides also are equal. Now, let's look at C. C is 75. So they say C is 75. Then ADB is going to be equals to 30. Okay. Prove that ABCD is a parallelogram. Now, remember, here you are proving that ABCD is a parallelogram. That's what you are dealing with here. But now, in this case, how are you going to do that? We will need things that support what we want. So for it to support what we want here, we need to have one of the properties of a parallelogram. So once we have one of the properties of a parallelogram, then we are good. So here in this case here, since we have got angles, maybe we have a high chance of us proving that opposite angles are equal. Or we are going to find that the sides are parallel. Okay, so we're going to find that the sides are parallel. We don't know, but we will find out. Now, let's start here. When we start, we're going to know, okay, D1 is something that we can deal with quickly. D1 is going to be equals to 75. Why 75? Because opposite, we already told that this side here is equal to this side here, and also that will make also equal to that side. But in this case, we are dealing with this part here. So because it's an isosceles, these are two isosceles. So in this case here, we are saying there's our angles opposite, equal sides. So this one will be 75. So we have now 75. So let's put in red. What we are finding out is 75. Now, what we also see that B1 is equal to 30. Now, when we have B1 is equal to 30, okay, so these are angles in a triangle. So here, angles in a triangle, they add up to 180. So here, so now we have got B1 is equal to 30. Now, B1 is equals to D2. So we have proved that. We have proved that D1 is equal to D2. So what can we say now? So we can now say, okay, if we have found that B1 is equals to what we call D2, we have proved. Then now, what can now say? Therefore, BC should be parallel to AD. Why are we saying parallel to AD? Because these are alternate angles. So we're looking at alternate angles here. Alternate angles are equal. So alternate angles of parallel lines. So here we're looking at alternate angles that are equal here. So once we see that, oh, there's an angle, these angles are alternate, but we find that they are equal, then now we can conclude that BC is parallel to AD. So that's what we have proved so far. Okay, we have proved that these two are parallel. Now, but we can't just go and now conclude that it's a parallelogram because it's only one side, one pair of sides that we have proved that they are what called parallel. What can we also do now is that, okay, let's try to find out what other angle we can find. So in this case here, we know that, okay, for us to get B1, B2, and what is it? And if these two are parallel, what else can we also see? We can now safely say this also co-interior angle, but yes. So we can now be able to find A. So how are we going to find A? Because we know that these two are parallel, but we can't because we can't. Okay, so in this case here, we need to find this angle here. We need to find this angle here. How are we going to find B2? We know that B2 will be equals to A. Why? Angle. So here we are saying angles opposite equal signs. So in that case, therefore, we can now say your B2 will be equals to 75. Okay, so B2 there will be 75. And now when you get B2 equals 75, these are also angles in a triangle. Okay, now B2 is 75, so B2 is 75. And here A is going to be also 75. Now, when we have that, we are now going to check here. When you look at this now, we can see that B2, B1 here, B is equals to D. And also as A is equals to C. So here what we see that B is equals to, let me use the different color there, is equals to D. And also that A AD, what is it? A will be equals to C. Now, when we have that, where are we getting this? We have proved. Now, therefore, we can now say ABC D is a parallelogram. Why do we say that opposite angles are equal? So opposite angles are what you call equal. So opposite angles here, we can just of parallelogram are equal. That's what we can say now. Okay, so in that case now, this is how we are supposed to prove, guys, when you're dealing with when you're proving that is a parallelogram. Okay, so let's go on and see our last question there. ABCD is a parallelogram. BD, ABCD is a parallelogram. So we have got A, BCD is a parallelogram. Now, if it's a parallelogram, we can now safely put this. I like doing this. Why? Because we are given that. So why not putting it up also? Now, what can we say also is that BD is equal and AC, BD and AC, BD and AC AC intersects at O, okay? AF is equals to OD, okay? Then CO is equals to FB, CO is equals to FB, okay? DA and BF, DA and BF, they are produced to meet at E. So, okay, no problem about that. Now, prove that BOAF is a parallelogram. That's what we need to know. So here we want to prove that BO, so BOAF, it is a parallelogram. What are we going to do now? We know we're going to say, okay, in this case, we're going to say our ABO will be equals to OD. BO is equals to OD. Y diagonals of parallelogram bisect. We are looking at this is a parallelogram here, but we are finding BO. Now let's also see AO is also equals to, before we continue, therefore, so here we see that FA, therefore FA is equals to BO. Why? We have proved that. Okay. Then the next one here is our AO. AO is equals to OC, because we're looking at this parallelogram that we are given already. So in that case here, diagonals of parallelogram bisect. Now, when we have that, so we can now conclude to say, therefore, AO will be equals to FB. We have proved that. Now, when we have that, so now what are we going to be seeing? That is that we are now seeing this. That's what we are seeing. So when we have that, we are now going to say, okay, A. So if these two are equal, then we are now saying FBOAF is a parallelogram. Let me just use the shortcut here. It's a parallelogram. Why are we saying that it's a parallelogram? Because opposite sides of parallelogram are equal. That's what we have there. So opposite sides here, we have proved that opposite sides are equal. Then we can now safely say this is a parallelogram. Now let's go on to 8.2. Prove that AD is equals to EA. AD is equals to EA. Okay. Now, if we prove that AD is equals to EA, we need to check here first, okay, that, okay, now, if we had to look at this, we have got AD, we also have BC there. So we can now link this BC with what you call EA, but how are we going to do that? That's the question. So I'm going to add something here so that you can see nicely here. Now, why am I adding that? I want to show you guys that these are all parallel. So here we are going to say, okay, what is it that we can do now? We can now find that we can now say what you call EA is parallel to your BC. why are we saying that it's parallel to BC? Is given. It's given that this is a parallelogram, and if it's a parallelogram, AD will be parallel to BC. So that's what we are given here. So it means that your AD will parallel to BC, and this is a collinear. It's just the same line that we're dealing with here. Now we are going now to say, okay, what about the other side? AO. We find that AO is parallel to BF. Okay, so in that case here, why are we saying that? Proved. So we have proved that this is a parallelogram. So it means that this side here is parallel to that side. Okay, so that will make the whole side parallel here. So when here is parallel and here is parallel, it also means it continues like that, okay, because it's in the same line. That's what we are saying here. Now, the other thing is that what we can also, once we have that, we can now safely say we can now say B, C, A, E is a parallelogram. And the reason being, opposite sides are parallel. Opposite sides of a parallelogram are parallel. That's what we know. So opposite of the parallelogram are parallel. Now, in that case, once we say that these opposites are parallel, now we know that EA is equal to BC. Now, when we have EA is equal to BC, your EA, that means also is equals to AD. Because what is it? This is a parallelogram as well. Okay, so here prove that EA is equals to AD. So we have proved that. So you can get your 4 marks from there, then you'll be fine. Okay, so guys, I think we now understand what you need to do when you are dealing with parallelograms, knowing the properties and remember them all. There are not many. You can just practice with your with your pen. Just complete everything there. Just make sure that your opposite angles are equal. Just make sure that your opposite sides are also equal. Then also make sure that your diagonals are bisecting each other. Then you also have to also prove that if one pair of opposite sides are equal and parallel, then the shape is a parallelogram. So those are the things that you must actually be remembering. Okay, that's what you need to understand. So when now you're putting your information together, there is no order to it. Yes, there is order though, but we are saying figure it out. You maybe write on a paper your things, write on a paper whatever comes to your mind. Okay, if it's a parallelogram, put your arrows first. So indicated by the arrows first. So if you are told that it's a parallelogram, put your arrows. When you put your arrows, it's going to help you. And again, another thing that you can also do is that show that these sides are then equal. So show that these sides are then equal. Yeah, opposite sides are then equal, because we have got we are told that it's a a parallelogram. Okay, so that's what you need to understand there. That's what you need to understand. I'm just going to circulate because we just added it now. Okay, so that's what you need to understand, guys. When you add that information, it's going to help you now to figure out some of the hidden things that in your diagram. So whatever you're given as a parallelogram, label it. Then you discover good things there. Okay, until next time, guys, all the best.